All right, 2.1, we're going to learn about quadratic functions. Anybody remember what a quadratic function is? Kayla?
It's a function where you have x is squared. You have x squared,
awesome,
x, and then a constant.
It's an x squared function. What does a graph of an x squared function look like? A parabola. So that's all we're dealing with in 2.1. So here we have the definition of a polynomial function. Poly means many, so many terms. Here we're just dealing with quadratic, so just x squared. In 2.2 we'll get to like x cubed, x to the 5th power, more terms than just an x squared. But here, just dealing with our x squared functions. So this is the standard form of a quadratic function. We have a is the coefficient in front of our x squared, b is the coefficient in front of our x, and c is our constant. The graph of a quadratic function is a parabola, just like we said. Parabolas occur in many real-life applications, especially those involving reflective properties, such as satellite dishes. Another question that we'll see actually in the homework is a question about like throwing a football. So if I was a person standing here and I was throwing a football, it would look like that and land over here. So this is like a parabola. So you can find the trajectory of a ball that you throw by using a quadratic function. All parabolas are symmetric with respect to a line across the axis of symmetry, which is just the axis of the parabola. And where the axis intersects the parabola is called the vertex of the parabola. So if I had a parabola here, the line that cuts it into two perfectly symmetrical pieces is our axis of symmetry. Where your axis of symmetry meets your parabola, that is your vertex. Depending on which direction your parabola opens, it's either going to be at the lowest point of your parabola or the highest point. So it'll either be at your minimum or your maximum.
What about on the side? If it's on the side?
That would not be a function because if we had a parabola that opened sideways, it fails the vertical line test, so it's not a function. So we're just dealing with ones that open up or open down.
Oh, I think it's
All right, so here are basic characteristics of a quadratic function. So when our leading coefficient is positive, so this says a is greater than 0, if it is positive, our graph is going to be a smiley face. It opens up. So that's when your leading coefficient is positive. Your domain of a quadratic function is always all real numbers.
So it's the same thing,
Even if it opens down, your domain is always all real numbers. Your range depends on where you start. If I started at 0 here, it would be 0 to infinity because it opens up. If my graph were shifted up to like 2, let's say, my range would be from 2 to infinity. So the range just depends on where you start. Our graph here has the intercept of 0, 0, so that's our x-intercept and our y-intercept because it crosses both the x-axis and the y-axis. It's decreasing and then it's increasing. It's an even function because it's symmetrical on the y-axis, so it's symmetrical here. So it's an even function. Our axis of symmetry is x is equal to 0, and then our relative minimum or vertex is at 0, 0. The next one has the same characteristics except it opens down, so this is when a is negative. So when your leading coefficient is negative, your graph is going to open down. The big difference here is that you have a relative max instead of a relative min. So when your graph opens down, your vertex is at the maximum point. So we need to sketch the graph of each function by hand and compare it with the graph of f of x is equal to x squared. So x squared, this is our parent function, that's just our basic parabola. In A and B, our parabola shifts and reflects. So just a rough sketch here. What do you think this negative does to our graph?
Makes it
Down.
face downward.
It flips it down, so it reflects it, so downwards. And then what do you think the +1 does to our graph?
One step.
It shifts it up 1.
It's not like this starting point of the graph, like,
Well, it's going to be where we start. So instead of our x squared, like our basic parabola would be here. That's our x squared, this one. We said our g of x here, so for A, reflects, so it goes down, but it also shifts up 1. So it would start here and just reflect down. So let's look at H. What does this +2 on the inside of our parentheses do?
So you go one.
Make it go left.
It makes it go left.
but,
So we go left 2. And then what about -3 on the outside?
Down.
Down 3.
Oh yeah, I forgot. The +2 is like opposite sides. So
Yep.
it'd be negative.
If it's inside the parentheses, it does the opposite of what you would think. So if it were minus, it would go to the right.
And now if it's on the outside, it's
Just the same. So like minus goes down, plus goes up. So our basic graph would start at 0, 0 and go here. So this is just our x squared. That's this one. But for B, we have to move to the left 2 and go down 3. So now our vertex is going to be down here, and then we just draw our parabola from there.
negative.
When your leading coefficient is negative, it opens down. So here, we don't have a negative out front, so it still opens up.
Wait, now say if it's, let's just say -2x squared.
If it were -2x squared,
Yeah.
what do you think, opens up or down?
Down, but like, it goes to
The 2 being multiplied to the x would make it
the wider.
wider. All right, this is just the solution to 1a and the solution to 1b. So in this book, it shows this as standard form. In other books, it calls this vertex form. So we're not really going to stress on like the name of the form that much. There's one question in WebAssign that says like, is this written in standard form? And it's written like this, so it'd be, yeah, it's written in standard form because this book does it this way. But we call it vertex form because you can clearly see your vertex. Your vertex is H, comma, K. So because your vertex is clearly visible here, that's why we call it vertex form, even though this book calls it standard form. So here we have our H and our K. The A out front will tell us if it opens up or down. H and K is our vertex. Notice how it's -H, so you always flip the sign of your H when you put it into your vertex. So describe the graph and identify the vertex.
The horizontal shift. Right?
It goes up. But this is in standard form.
Oh, so
And we want to identify the vertex, so we want to put it into the vertex form where we can clearly see. So a couple different ways we could do that. We can find the vertex, which the formula for the vertex I think is actually on the next page. But I'll just skip ahead and tell you what it is. So our vertex, to find it, would be -b over 2a. That's our x value of our vertex. Anybody remember how to find the y value of our vertex?
so you just plug it in.
Plug it in. So it would be like f of -b over 2a. You just plug it in. So plug in x to find y. Good job. So what's my a? 2. What's my b? 8. So I want to plug that into my negative b over 2a to find my x value in my vertex. So I have negative 8 over 2 times 2. So this would be negative 8 over 4, which simplifies to what? Negative 2. So in my vertex here, my x is negative 2. How do I find my y? Plug it in. So I'm going to take my negative 2, plug it into all the x's in my equation. So I have 2 times negative 2 squared plus 8 times negative 2 plus 7. So negative 2 squared would be 4, so 2 times 4, which would be 8. Then it would be minus 16 plus 7. Negative 1. So my vertex is negative 2 comma negative 1. So,
Is that all we have to do?
well, I'm going to show you approximately what the graph would look like. This one just says describe the graph. But our vertex, we said, is going to be at negative 2, negative 1. So we go to the left 2, down 1. That's our vertex. Does this graph open up or down?
Wait, no, up, sorry.
It opens up because our A is positive, so it's going to open up. Another characteristic that we can see about our graph when it is in standard form like this is that this value, our C value, is our y-intercept. So we cross the y-axis at 7.
Wait, that's standard form right there?
Yes. So we're going to cross the y-axis at 7 here. So that's just another piece of information that we can tell when it's given to us in standard form like this.
Wait, what?
The C value is our y-intercept.
Wait, I thought the other one was standard.
So what do we have to do with the y?
So does my graph have a maximum or a minimum at the vertex? A minimum. And what do you think my minimum value is? Negative 1. It's always the y value in your vertex. So my minimum is the lowest y value, so that would be at negative 1. And what do you think my axis of symmetry is? Just negative 2?
A negative 1.
Axis of symmetry is a line. So it's a line that goes through negative 2.
Right, x equals negative.
X equals negative 2. So whenever you write your axis of symmetry, you need that x equals because it's a line. So this was our vertex. One last thing that I'm going to make you find here, even though this question doesn't really ask for it, is to put this into vertex form. So how do you think I would write this in vertex form? So my vertex form is y is equal to a times x minus h squared plus k.
Well, you have your h and k already.
I have my h and k already.
You have a, I guess.
A is 2. You are right. So x minus, what's our h?
It would be negative 8. You have minus 8, sorry, it would be 8.
So it would be,
Oh, 2, wrong shipping. I'm looking at, minus 2.
so it's a minus
plus.
negative 2, so it becomes a plus 2. So x plus 2, and then what are we adding on the outside?
Minus
Minus 1. So this would be our vertex form.
So the h and the k is just the vertex?
Mm-hmm. H and k. So this is your h, this is your k. So you just plug that in. How did you know that this number was 2 out front?
Because
Because A is 2. Awesome. A lot of the questions from the homework are like this, where you have to write it in this form. So it'll give it to you like this, and you just have to identify the vertex using this formula here, negative b over 2a, and then put it into this form. Any questions here? Form, and how did you know? All right, this is the solution to it. here we are finding the maximum and minimum values. So it just says that the vertex of the graph is this formula here. So it's the same thing we just did, negative b over 2a. To find the y, you plug in x. And then whether you have a maximum or minimum depends on which way you open. So if we open up, do we have a max or min? A minimum. So the vertex would be at the minimum. And if we open down, we have max or min?
Maximum.
Maximum. So your vertex is at the maximum. This is just saying the same thing. The minimum value is your y value. Same thing with the maximum, it's your y value. If it gives it to you in standard form like this, where you have a times x squared plus bx plus c, you can find the vertex by using this formula. So exactly what we just did. Yes. And then our last question is this one. So given a point and a vertex, write the equation of the parabola in standard form, which is the vertex form here. So even though this book calls it standard form, we want it like this. So what should I do? Plug in all the stuff. So this is a point that I was given, negative 7, 3, and my vertex. So I know my vertex, I have h and k. So I'm going to plug in h and k. So I have y is equal to a times x minus h, so minus 4 squared plus k, so minus 1. What else can I plug in?
You can plug in that x, right?
Right. So I have a value for x and y here. So I can plug in x and y into x and y. So I can say that this is 3 is equal to a times x is negative 7.
Find your a.
This is to find my a. Awesome. It doesn't give me what my a value is. I have everything else. I have an x and y and h and k, but I don't have that a value, so I'm going to solve for a. So what do you think I should do to solve for a? Add 1 to both sides. So I have 4 is equal to a times, I'm going to add what's in the parentheses or subtract, so negative 11 squared. What can I do next?
Square 11.
Square negative 11, so that would be 4 is equal to 121a. Divide both sides by 121. So a is equal to what? 4 over 121. So I'm going to take my a, my h, and my k and plug them back into my vertex form, and that's my answer. So I have f of x, or y, is equal to, my a is 4 over 121 times x minus h, so minus 4, squared minus 1. And that would be my answer. So if it gives you a point and the vertex, you have to find a. So plug everything in, find a, and then you plug in your a and your h and k into your answer.